Hi everyone, myself Bidyutlata Sahoo, working as an assistant professor in the Department of CSE, Artificial Intelligence and Machine Learning at Institute of Aeronautical Engineering, Hyderabad. In this video lecture today, I am going to discuss about the robotic perception. In my previous video lecture, already I have introduced what is the meaning of robotics and what is the difference between robotics and the robot. Even I discussed about what are the hardware components are required for the designing of the robot. Now, how in this video lecture, I'll discuss how a robot can receive the information from the environment, which is called as the robotic perception. So these are the topics to be discussed. I will discuss now in this video lecture. First, we'll understand what is the meaning of perception. Then what are the key components of robotic perception. Then we'll discuss the meaning of localization and mapping. And in this localization and mapping, two different techniques or methods I'll discuss, which are very important, and these two techniques are also given in Peter Novick book. You can refer it. A simplified kinematic model of a mobile robot and a sensor model. So using these two models, how the robot can move from one place to another place as well as it receives the information. And last, which is nothing but the advanced technique of perception, we are using machine learning in robotics. So this is the topic learning outcome for the robotic perception. After the completion of the topic, students can explain how the robots use the sensor data to perceive and interpret their environment. Let me discuss about this picture. This picture is about an intelligent agent structure. We ourselves can also be considered as an agent. We have sensors like sense organs like eyes, ears, nose, tongue, so your skin. All these using all these sense organs, we can sense the things from the environment, and after sensing, then all the information goes to our nervous system or the brain. Then brain used to process it. Then based upon the informations or data, then with the help of our hand and legs, we can perform the action. The same thing we can consider the agent concept in artificial intelligence. That agent can be here a AI software, or it can be AI application, or anything we can consider, or we can say it may be a robot, or it may be a drone. Okay, so anything you consider as an agent. So agent have two important things. One is it can perceive, that means it can receive the information from the environment. This is environment. So here is the agent. Agent can receive the informations or the data or the knowledge through the sensors, because sensors are there. Different types of sensors are also there. Like if the robot or if the agent is present in a heat environment, then the temperature sensor is required. If the robot or if the agent is in the light environment, then light sensor is required to receive the information from the environment. So that receiving of information through the sensors is called as perception. And after receiving the data, then agent used to process that information with its reasoning capability. Then it again performs the action on the environment itself. So how it performs, and one more thing is there, the actuators, effectors. Effectors are related to this intelligent agent structure. Effectors are nothing but the tools which are used to perform the action, like gripping the object or holding the object, moving the object from one place to another place. That can be possible with the help of effectors. And actions, what type of actions the agent can perform to the environment? Like it can move, either it can perform the transitional movement, okay, or else it can perform the rotational movement. So both these kind of movements are considered as the action to the environment, right? So what we have understood from this picture, this is the logical agent which is having sensors and actuators and effectors. Through the sensors, it can perceive the information from the environment, which is called as perception. After receiving the data, it process it or reason it, then it performs the action, means either it moves in two-dimensional space or three-dimensional space, which is called as the transitional movement, or else it can rotate also, like this transition around x-axis, transition about y-axis, transition around z-axis, which is called as the rotational movement, as well as it also perform the effectors, means it can move the content or move the object, it can hold the object, it can tight the object. So all these operations it can perform, those are called as effectors. So this is all about the logical agent. Now, what do you mean by robotic perception? I hope you might have understood from that picture itself. Now, let me repeat theoretically. So, robotic perception refers to a robot's ability to sense, interpret, and understand its environment using sensors and algorithms. So robots will have the sensors, different types of sensors, maybe light sensor or pressure sensor or heat sensor, depending upon the context. That sensor will have the capability to sense and to understand and to reason also. It enables the robot to gather the information or the data about the world, then it processes it and make informed decision based on that information. So after receiving, then it process or reason, try to understand what action needs to be taken care by the agent. So based on that, it takes the action. So perception, basically it is very difficult because the sensors are noisy and the environment is partially observable or unpredictable and often dynamic also. Like, why the perception? As I told, perception means receiving the information through the senses. It is easy, but sometimes it is difficult because of the environmental condition or because of the senses condition. That is why it is called as sensors are noisy. Sensor does not make any noise, but the technical term what we use, that sensors are noisy. When we can say the sensors are noisy, when the sensor will not, sensors cannot receive the information from the environment. That means the environment is unpredictable or which is very noisy. Sensor is not having the capability to receive the information from the environment. The environment is partially visible to the logical agent, or the environment which is unpredictable, like a foggy environment where the drone moves, or the logical agent, the robot works in a search and rescue environment. So those environments are unpredictable environment. In that environment, perception would be difficult. Means receiving of information from the environment would be difficult. Or else we can say the example of if the environment is fully dynamic. If you take the example of the self-driving car, when car moves on the street and with huge traffic, it cannot predict how much traffic would be there after 1 second or after 2 seconds. So up to certain distance, like 50-meter distance or 100-meter distance, it can observe and it can take its own precaution, but beyond that it cannot take. So that type of environment is called as dynamic environment, means ever-changing environment. Where there also sensors are very difficult to receive the information from its environment. Then we can say perception is very difficult for the agent in these cases. If the environment is partially observable, if the environment is unpredictable, if the environment is also dynamic. And all these problems of robot are called as state estimation. So partial observable, whether it is unpredictable, these are different states where the sensors works to try to receive the information from the environment. So each state is called as the state estimation. Now, these are the key components of the robotic perception. The first one is the sensors. Second one is the signal processing. Third one is the feature extraction. Fourth one is the scene understanding, and fifth one is the localization and mapping, and sixth one, the object recognition and tracking. So what is the meaning? The first component is very important, which are called as the sensors. Sensors are the hardware devices which are used in the robot to collect the data from the environment. So cameras can be used. In camera, light sensors are there, LIDAR sensors, ultrasonic sensors, or infrared sensors, or microphones. Those type of sensors. In microphone, sound sensors are there. So all these sensors, what they are responsible to receive the data from the environment. Then signal processing. Signal processing means converting the raw sensor data into the usable format. So though data will be received by the sensors, the raw data which is in the analog format, that cannot be represented or that cannot be understandable by the central processing unit of the system or the robot. So that is why that raw data which are received through the sensors should be encoded into a usable format. That format may be different knowledge representation technique, or that format may be in encoded format or in any programming language. So that processing is called as signal processing, conversion of the raw data into usable format or digital format. Then the next component is the feature extraction. Feature extraction means extraction of important features or the characteristics from the raw data. So as many raw data are received through the sensors, to solve a particular problem, it may not require all the features at a time. So the features which have the correct impact or which have the high impact to find out the solution, those features needs to be processed or needs to be extracted from the overall features. So that terminology is called as feature extraction. So feature extraction means identifying the important elements from the process data. Like for example, the drone has to identify where the object is or where the obstacle is. So it has to, so the important feature, what would be the feature for the object or the image, like the edges of the image, or what would be the shape of the object, and what would be the motion pattern of the object, that needs to be retrieved or needs to be extracted for the robot. Then the next component is skin understanding. Skin understanding says that interpreting the features to understand object, people, retain, and obstacle. That means in the third stage, during feature extraction, the important features are identified, and based upon the feature, the robot should have the ability to understand the scene, that object based on the image, based upon the shape, whether it is a circular object or whether it is a rough object, that can be understandable by the logical agent. So this is also one of the component for robotic perception. Why I'm discussing all these components? While exploring, during the exploration of the robot, it needs to consider all the components, whether it is understanding the features, whether it is receiving the data from the environment, whether it's able to process the data, even whether it is able to identify what type of object is there through the skin understanding concept. The next component is localization and mapping. So localization and mapping means knowing where the robot is present and building a map of the environment, which is called as mapping. That means whenever we purchase a robotic vacuum cleaner, initially doesn't know about the layout of the home, and it doesn't know about where the object is present. So it tries to explore where the object is present while exploring the path in our home. And how, while exploring, it also try to map the environmental conditions or the map of the complete layout of the home in the software of the robot, which is called as mapping. So that is why we used to consider different spaces. The real space where the robot is present, that is called as the workspace, and the space where inside the virtual space, which is configured with the help of software, that is called as the configuration space. Now the next term is object recognition and tracking. So object recognition, the agent has to identify and following specific objects or people over time. So these are the important components for the robotic perception. Now let me discuss what are the good internal representation for the robots have three important properties. The internal representation of the robots have three important properties. First, they can contain the enough amount of information for the robot to make good decisions. They are structured so that they can be updated efficiently, and they are very natural in the sense that internal variables correspond to natural state variables in the physical world. So that is why they should contain enough amount of information so that robot can take the decision. How the robot can take the decision? If the sensors are in good condition, if the sensors have the capability to receive the information from the outside world in a perfect way, then it can take the decision. And all the information should be in the structured format. Means one rule or one knowledge should not be different from another rule. That is called as the structured representation of the knowledge. The knowledge should be structured, and they are very natural sense there, so that the robot or the agent can interact with the outside world. Now, localization is one of the problems. This concept is very important. Now I'm going to discuss in robotic perception, as sensors are used to help or used to receive the information from the outside world. After sensing, how it localizes where the robot is present, what is its internal state. So that concept is we will discuss over here. Out of all the 6 components, this is one of the component which is called as localization, and I'll discuss 2 important methods for this localization to understand. So localization, it is the problem of determining the position of the object, including the robot itself within the environment. That is called as localization, where it is present. Now I will show you one diagram. Let me tell you what is the concept behind that localization and mapping. Let us consider a mobile robot. The robot which can move, that is called as the mobile robot, that moves slowly in a flat 2D wall, and assume the robot is given an exact map of the environment. The mobile robot is defined by its 2 Cartesian coordinates, one is x and y, and along with its heading theta. Okay, so we are considering one mobile robot which can move either x direction or y direction. Even it can take the angular direction theta also. This is x direction, this is y direction. It can move in angular direction also. So if we arrange, now mathematically how we can represent the movement of the robot. This is the representation. If we arrange these 3 variables in a vector format, then any particular state at a moment of time, we can represent x of t, that is equal to xt, yt and theta t. So xt means the movement along the x-axis at time t, yt means the movement along y-axis at the time t, and theta t means the movement along this axis. It may be some other axis or some other direction, taking an angle theta at a time t. So this is the mathematical representation of the movement of the robot when at the time t. Now this is one of the model way for this localization technique to understand a simplified kinematic model of a mobile robot, how the robot moves from one place to another place after sensing the information. Now initially the robot is present at this place which is represented as x of t. So at the time t, the robot is present. Now robot is moving. Robot can move, as I told, it can move in x direction, it can move in y direction also. Here robot is moving in the x direction, okay, with a displacement of delta t. Here it is given, and vt is the linear velocity. It is following the linear velocity v with respect to time t, and a angular and a displacement of delta t. As well as robot can move in an angular direction by taking an angle theta t also. This is also possible. Okay, now if the robot moves in a straight line, which is called as the forward movement, from this xt, it can reach to xt plus 1. Right now, from this is the destination location, this is the initial location. Now from this destination location, a robot again it can take the angular movement, which can be theta t plus 1, or it can be it can take another movement which is called as the omega t, and with a linear displacement of t, that is called as the angular movement, either this direction, or if it is a straight line again, so with respect to this line, this movement would be there, and if the robot moves in this direction, then another angle it may take. Okay, so this is the way the robot can move, and it depends upon how much distance it covers, that is denoted as the linear displacement, as well as it also depends upon the velocity of the velocity of the movement, which is denoted as either vt or w omega of t. This is linear velocity, this is the angular velocity, we can say w of t is the angular velocity, this is angular angle. Okay, and one of the objects, suppose the object is present here, the object which is present at a distance of h of xt. So using this movement, this can be represented as xi and yi. Okay, here it is not properly visible, and the distance from here, the main object, to this initial position of the robot, let it be h of xt. So same for formula we can apply. If we know the value of velocity and the angular movement, definitely we can find out how the robot will perceive and how the robot can reach to the destination, means to achieve this object. so which is denoted as H of T here. So this is the explanation about the kinematic model of the mobile robot, because it is related to where the robot is moving. And I will show you another example, that is sensor model. Okay, in this example, robot is moving with a linear velocity as well as the angular velocity. But here the robot is now, here how the robotic perception can be achieved using sensors. Now, this is one robot and this is another robot, and this gray color option which is given, that is the surface, we can say. Now here robot, for this particular robot is like emitting 4 different signals, light signals, let it be Z1, Z2 and Z3 and Z4. So whenever it emits all the signals to the surface, and all the signals, the light signals, it interacts with the surface, and how much light is reflected back to the robot, then it can understand that if all the light is coming back to the robot, or maximum percentage of light is coming back to the robot, then it can be understood that the object will be visible. That means, that is why the complete this gray picture is looking, this object is looking like gray for this particular robot. But if you consider this robot is also emitting all the 4 signals, this one, this one, this one, this one. But out of all the 4 signals, only 2 signals are interacting with this object. That is why partly it is visible, not fully visible. One ray is going beyond, another ray is going outside, so which is not interacting with the object. So that is why, because of these 2 rays, as it is interacting with the object, and the same amount of light energy or light is getting back to the robot, so that is why the object is partially visible, it is not fully visible. So this is one of the concept of localization, how the robot can sense with the help of light sensors how much light is getting back once it receives the light, emitting the light, how much light energy is getting back. Based on that, the object will be visible to the robot. So this is one of the concept or the method used in the robotic localization concept, which is also called as the range scan, because it scans the range of object with the help of light signals. The same thing is also applied for sound signal also. Now, one of the important technique we'll discuss nowadays, machine learning is also used in case of the robotic perception. Why machine learning algorithms? Because machine learning is having the capability of self-learning and self-adaptability capability, which is not possible using normal AI algorithms. So machine learning plays a crucial role in robotic perception. When the optimal internal representation is unknown, then machine learning provides an effective solution. A common approach involves using unsupervised machine learning methods to map high-dimensional sensors data into low-dimensional spaces, a technique which is known as low-dimensional embedding. Okay, so using machine learning, especially the unsupervised machine learning algorithm, is used to map the high-dimensional sensor data into low-dimensional space. What is the meaning of this statement? So unsupervised machine learning methods where the output will the both input and outputs, any one thing is required, means input will be given, the corresponding output will not be there. So based upon the input data, how the algorithm can recognize the structure or the pattern of the information or the data, that can be done using unsupervised learning. So based on the only input features, it can make the cluster or it can do the classification. And what is the meaning of to map high dimensional data? If the dimension of the data, if the dimension of the data in 3D, then we can change to 2D data. 3D data, it takes more space compared to the 2D data, or 2D data we can convert into 1 data. Sometimes in machine learning also we used to consider if all the features are not relevant, we can reduce the number of features to make the algorithm effective. That is also called as reducing the dimension from higher dimension to the lower dimensional space. So that is called as low dimensional embedding in machine learning. So these type of advanced techniques are used in the robotic perception, so that instead of sensors also, they can learn, they can explore the environment, robot can explore the environment, they can learn, and they can be adaptable to the dynamic changes. Now, let me discuss what are the key advantages of machine learning in robotic perception. The ability to learn sensor and motion models directly from the data. They have the ability to learn by directly from the data itself. It does not require any sensors or any techniques. And simultaneous discovery of appropriate internal representation. It automatically it can understand the structure, the pattern of data, or the internal structure of the robot or the object. It can handle complex perception tasks where traditional modeling approach may fail. That means it can handle the complex situations. And this data-driven approach enables the robot to develop more robust and adaptive perception capabilities. If the situation is too complex, machine learning algorithms like neural networks or artificial neural networks helps to learn from the data. They can adaptable to the new situation, as well as they can explore the environment also. So machine learning techniques enables the robot to continuously adapt to huge changes in sensors environment. Like for example, now I will show you, this is a classic example, how machine learning works, how our brain works, how machine learning works, almost similar. Now, when walking from a sunlit space into the dark neon lit room, things are clearly darkened inside. However, the change of light source also affect all the colors. That means what? Let me show the example in the form of picture. Now suppose you are coming with your friend, this picture. Okay, you are coming from the outside, means sunny environment, to the room which is having neon lit room. This is a room which is neon lit room, which is green in color, but outside as it is sunny, it was yellow in color. So what your eyes perceived or eyes are acquainted with the natural environment of like outside, the sunlight environment. Immediately when you enter into the neon lit room, what happens? Suddenly your face, your color and your friend's face color will be changed. Still your mind works and you can recognize your friend's face clearly because your mind has already acquainted with all the features of your friend's face. The same thing happens in the machine learning also. Even if the situation is dynamic or it is unpredictable, it can understand the pattern of data and quickly it will adapt and it will try to make the changes. This is what the machine learning techniques are used in the case of perception. Now, the same way machine learning helps the robot to do the same thing, like it can continuously learn and it can adapt to the dynamic situation. And robust feature extraction, it can extract the important features out of all unnecessary features which are not required, and no need of hard coding required. Once the learning model is trained, next time coding is not required. Automatically it can learn the pattern from the data and it will be adaptable to find out either it can do the prediction or it can do the classification or it can do the clustering and self-correction over time. It has the machine learning algorithm is having the capability to update or to correct itself over time. So because of that, robotic perception would be very easy in case of the robot. Even though sensor receives some noisy data from the environment, it can make the correction by itself and it will try to adapt to the situation, then it will continue for the exploration. So this is all about for this particular video. I hope you might have understood. So for this video, I have referred this book, Russell and Novick book, which is given on the screen. For your reference, I kept the picture. You can understand and you can also purchase from the Amazon website. Thank you so much.
Like, share and subscribe. Hit the bell icon for more updates.